My name is Cody Van Cleve, and I'm the team lead for our capstone design project. In general, it's kind of an interesting concept. This cell was meant to showcase industrial automation features that might be interesting to potential customers looking to get into automation. So what I mean by that is this cell utilizes a machine vision camera to identify parts and pick and place them. It uses PLC integration, so the robot's actually talking with a controller in the cabinet that's coordinating all of the actions in the cell, like the conveyor and the turntable. So the robot actually interacts with those parts intelligently by design. The cell is completely safe. If you were to walk up to it and stick a hand inside the cell, the system would shut down. And there's a safety controller inside our control cabinet that specifically monitors our safety inputs and controls the safety outputs. So many of the features on this cell, although the purpose is atypical, as you can see, it picks up pieces and places them into the segment wall to spell out words or phrases. It's done with very typical components. So in this way, it's kind of entertaining, but also showcases parts that you would find in a standard automation installation.
My name is Eric Rogers, and I am the software lead for the capstone project. Probably the most challenging thing about this project was learning all of the programming languages that I needed to make the cell work, and then making them work together. So I had to code the PLC, which is in the control cabinet, the robot, which is outside the control cabinet, and then the distributed Ethernet motors, which are in the cell. I would say the most interesting part was, again, learning how to use all the languages and make them work together, and then also programming the robot for the first time, because that's something I'd never done.
My name is Preston Wilson. I was the electrical lead. Primary focus was on the design and build of the control cabinet. So our system runs on 480 volts AC three-phase coming out of the wall. That powers the robot. It also goes to the transformer, which brings it down to 240/120. Several components run on the 240 and the 120, and then we also have many components that run on the 24 volts DC. It was quite challenging to integrate all the different components on different power rails.
Hi, my name is Frank Ross. I was the mechanical team lead for this project. So as a mechanical team lead, I was in charge of designing the frame that the robot's sitting on, making sure that it would withstand the load that was applied to it with FEA testing through SolidWorks, as well as various other tasks as machining the segment wall and machining of the individual segments that are going into the wall. So most challenging, when I came into the project, I thought it was going to be a very simple task, basically buying some power supplies, buying some a PLC, wiring them all together, and writing a program. Going into it though, I realized how much more there was into designing an automation system that I didn't see from the beginning.
My name is Josh Kosar. I was in charge of primarily designing and building the part handling system to return all of the pieces from the segment board over to the machine vision imaging area. The most challenging part about this was that every time we built something up to fix kind of pieces falling out or going in a different way than we expected, they'd find a new way out of the kind of track they're supposed to go in, and it was kind of this fix one hole and you know, the next weakest part opens up.
Hello, my name is Touchston, and for my part of the project, I integrated the pneumatics and created the adapter for the end effector. What I found most challenging was how open-ended everything is with integration. We could have used electronics versus pneumatics for anything, and the amount of parts available were almost endless. So it was just defining and then choosing a correct solution. The pneumatic system works by using our shop air and running it through a filter regulator. This prevents any fluid from being in the lines and damaging any parts. Next we have our vacuum generators, and that's what allows our vacuum pads to pick up the pieces and put them in the segment wall. Other than that, in the back behind the segment wall, we have pneumatic cylinders that pop out all the pieces when we're ready to put in another phrase.
I want to give a special thanks to all those that really made this project possible. Jerry Gintz for providing his lab space for a considerable amount of time and his expertise in some of the details of the build. Rhett and Scott Allman, thank you so much for providing the facilities we needed. I mean, every part of this project was built here in this building, from the CNC manufacturing to the manual milling to the manual lathe processes, to the bending to the welding. Everything was done here, and you know, Rhett, you were of amazing help when it came time to put all the parts on the CNC. We had a lot of challenges there, and it went incredibly smoothly with your assistance. And thank you especially to Delta Technologies for making this possible. Your partnership and your sponsorship is the reason that this project materialized as well as it did. And we're very grateful for your help along the way. And to all of our industry partners and everybody else that were able to come in and fill in the gaps and help us overcome obstacles that I don't know if we would have been able to otherwise. We're especially grateful for you. So thank you so much for believing in our team and believing in this idea.
So Jasper, what was your favorite part about this project?
Told you, as soon as we get him in front of the mic, silent.